Hello, I am Brock Stanton. I'm an aspiring meteorologist, and today we are going to be taking a look at this enhanced risk across portions of southeastern Alabama into western Georgia. But we're also going to be taking a look at some other areas in this broad slight risk. The other two areas are probably going to be a little further north across portions of eastern Kentucky and Tennessee and maybe western North Carolina, as well as southern Virginia and parts of North Carolina as well. Those are two areas that could see a greater severe weather threat evolve. The Storm Protection Center explicitly mentions in their outlook that some of those areas could be upgraded to an enhanced risk if confidence increases in the scenario that could warrant an enhanced risk. First, we're going to be taking a look at our southern mode, though, on the 18Z HRRR, and we're going to see here how, as we move into the afternoon hours, the HRRR will develop these supercells here. It's mixed mode, but it'll be some supercells developing. This environment does have some pretty decent shearing profiles. There is a 10% chance for tornadoes within a 25 miles radius for this area. Here I realize I never showed the probabilities. Here's our 10% for tornadoes down there, and another 5% there. And then we have our 30% wind. It's just a reference point, but again, as we continue to move through, we see these storms develop, and again, there will be some pretty good shear profiles that could support a tornado threat with any of these supercell storms that do evolve. And we're just going to take a sounding here, see what it looks like. You can see there's a little bit of turning in the photograph. It's not the most turning in the photographs for sure, but you can see we have our favorable cape, 1,000 to 2,000 cape. That's going to be sufficient, and our lapse rates our mid-level lapse rates are pretty bad, but our low-level lapse rates are favorable, and that's pretty important for our damaging wind risk, our low-level lapse rates. So that gives me some confidence that with the damaging wind risk, we'll end up verifying. Tornado threat's still a little bit uncertain, though. I do see how the 10% is warranted. I do agree with the Storm Prediction Center on that. Just going to continue to place a little bit further. You can see these storms develop, and as they'll move their way eastward, and you see maybe form into some clusters into the overnight hours, and evening and overnight hours, and continuing chance for damaging winds. We are going to be taking a look at our 850 jet first, just to show that strong low-level shear. And we're going to see as we get into the afternoon, we're going to see the 850 winds are going to be, we have 40 to 50 knots, 35 to 50 knot 850 jet overspreading the warm sector. So that's going to serve to be pretty favorable for tornadic storms. And again, there's not the most curving with the photograph, but there's going to be at least just enough curving to see a tornado risk, and our speed shear profiles with how powerful the low-level jet is going to, again, support that tornado risk, going to support that damaging wind with our strong 850 jet. And we can see how this is going to spread up eastward, and that's going to support the risk of tornadoes later in the day in Virginia and North Carolina. But we will get to that risk later. What we're going to look at next is our cape. And we're going to see how, as we move into the afternoon hours, we have a corridor of moderate instability develop. Pretty widespread 1,000, perhaps 1,000 to 2,000 cape, mixed layer cape, and that's going to be supportive. Again, that's going to support all hazards. We really look for more than 1,000 cape, and we have that in this situation. It's not any sort of extreme cape setup, but it's certainly enough to support our severe weather risk. We're going to take a look at our lapse rates next. And this is one of the things that aren't too favorable for this risk, is that we can see our lapse rates, mid-levels, are going to be pretty poor. Here, I'm generally around 6, maybe a little less, depending on what HRRR says, a little less than 6, NAM says a little bit more. So generally lapse rates of around 6, and that's really just marginally favorable for severe weather. 6 I wouldn't even really call favorable, just really neutral either way. So that's one of the things that casts a little bit of uncertainty on this risk. But again, overall our shear profiles are going to be pretty good. We're going to see how we're going to have supportive bulk shear here. Really, anywhere where we see these dark blue colors is going to be supportive, or like purple colors, these dark blue to purple colors. So that, again, that's going to support our storms organizing potentially into supercells, and if not, some organized cluster of storms still, and so that will support our all hazards risk. Taking a look at our storm relative helicity values, SRH, we're going to see how they're going to, again, I think especially across western Georgia, they're going to be the highest. They're not going to be crazy strong values, but generally on the HRR, have the corridor that's going to form in western Georgia, and then kind of move eastward. And I do think here that's where our greatest tornado risk will be, in my opinion. But we'll just have to see. And we can see we have the little more turning in the photograph and that sounding. Still not the greatest, but again, that's gonna fuel that greater tornado risk. And 0 to 3 storm relative helicity is going to tell a pretty similar story. I think Georgia, again, especially western Georgia, just based off of storm coverage and stuff, I do think it's going to have the greatest tornado risk, but we'll see because things can still change between now and then. Taking a look at our, let's see, we're going to take a look at our, blanking on me what I should look at next. Is there anything else here? No, take a look at our surface-based CAPE photograph before we're going to switch over to different models for our future days. And we're going to see here how, our photographs, they're going to curve some, but not too much. That's one good thing that's going to probably stop this from being a bigger, higher end tornado event. Certainly some tornadoes, but this is not going to be like a major tornado outbreak. Maybe a more localized tornado outbreak, but it's going to be a very localized outbreak. Is kind of more of a higher end scenario for this setup. So I don't think outbreak was the best terminology for that, but like a localized greater tornado corridor could end up developing somewhere from eastern Alabama into western Georgia. So that's a look at our HRR for this. Now we are going to take a look at our HRR for the other modes now. We're going to take a look at our reflectivity first. And we're going to see, so this mode, it starts to form a little later in the evening hours. Here, you can see our HRR is going to fire these clusters of storms here, perhaps a chance at a supercell. But it's this risk of severe weather across like northern North Carolina and southern Virginia, very, very uncertain, but it could be again a localized heightened risk of tornadoes. We can see how these supercells do fire, and it's a pretty localized risk because just north of these storms here, let's see if this sounding shows it, but just a little bit to the north of here, there's going to be a warm front, and there's basically, and if we go a little further north, I think we'll see that. Let's see the temperatures have dropped. You see, look, now they've dropped into the 60s, despite not being any rain nearby because of that warm front lifting north. It's going to be a very narrow corridor of severe weather. But another thing is that when storms ride frontal boundaries, there's some localized more spin in the air, so that can lead to a localized greater tornado risk. So if any one of those storms can anchor on the warm front, that would provide a greater tornado risk with that storm in particular. We are going to be taking a look at our CAPE now, mixed layer CAPE. And we're going to see how the CAPE just arrives late, but it seems to arrive just in time, again, as that warmer air comes in with the warm front passing to its north, and then see here's a warm front right here. It's going to be roughly where it is. And we can see how just south of that warm front there is going to be a favorable instability axis to support that tornado and damaging wind risk. We could see some instances of hail as well, really, with any storms in this area, in any area where in the slight risk on these 2 days, though I do think tornadoes and damaging winds are going to be the more significant of those two hazards. And we're going to just check out our elapsed rates and see what this model tries to do with them. And again, they look fairly marginal. I think that's going to be the case with all the 3 areas we're going to be taking a look at for this system. But now we're going to take a look at our 850 jet, and this is going to be pretty favorable as well. Here, let's to load in for us. And we're going to see it's really coming in like just in time, and by 23:00, this is when storms are ongoing. See their level is just starting to sneak in. You can see we do have that curving in the photograph, sufficient cape in that sounding, but it's really just going to come down to how these very small scale details are going to come together. Because if the storms are just north of the 850 jet, or the warm front doesn't lift far enough north, or the storms don't stay isolated, that any one of those things can kind of mess up the tornado threat, and that would be great news. But it's just kind of unclear how these mesoscale details are going to play out. By mesoscale details, I mean small-scale details. But if they do play out in a way that's more favorable for tornadoes, and the SPC realizes that there could be a 10% area warranted, but by the day one time period, we're just going to have to watch those mesoscale details and see if that does come to be the case. And then the next thing we're going to take a look at is our storm relative helicity values. So just for a refresher, and I haven't done this in a while, what our storm relative helicity values are is the horizontal motion, like this, spinning horizontal motion in the air. And a tornado is the updraft being stretched down to the ground as a tornado violently rotating updraft. So if we have this vertical if we have this horizontal motion like this, and we have a strong updraft, then that can get translated down into a tornado. So this is a very important ingredient to determine our tornado potential. And you can see here how as our 850 jet increases, that this environment of actually pretty favorable storm relative helicity. I mean, that's by 0Z, it's 200 to 300 storm relative helicity. Generally, for a strong tornado threat, you look for over 200. Now, I'm not sure that's going to be the case, just based off how all the other factors have to line up perfectly to get this to have this to matter. But our storm relative helicity values are going to be very supportive for tornadoes, so that's something to watch. That if we can get a storm to form right along that warm front or stay isolated, then that's what could watch to warrant higher tornado probabilities across this area. And that's why you don't just want to tune out of weather a couple of days out, because these things can come together just the day of or day before, and we didn't really think that would be happening. I've been busy following other severe weather, so I haven't been following this until today, but again, that's just something like weather can change so much so rapidly. Again, our 0 to 3 storm relative helicity values, again, are going to be very favorable across this corridor for Carolinas into Virginia. So anything else I should look at here? Let's take a look at our bulk shear. This is also going to be favorable for organized clusters of storms. You can see how by 0Z we still have this environment of, again, we generally look for these purple values and dark blues, and again, we can see we're going to have those in place. So that will serve our organized updrafts, and we're just going to see small scale details to see if they stay more discrete supercells or if they become a little more clustered. So we are going to take a quick look at the Ohio Valley area before we take a really brief look at our NAM. I want to go more in depth on this, but I have to get ready for work in a half an hour, and I still have to edit this, so we're kind of going to be in rapid fire mode from here on out. So I apologize if I'm moving too quickly, but it's really the only way I have time to cover any of this. So we're going to take a look at our H-bar here, and we're going to see how these storms do develop in at least a somewhat favorable thermodynamic environment. I'll show that in a second. There's a little bit of uncertainty with how favorable the thermodynamic environment is going to be because of potential showers early on, that like you're seeing here, this cluster of storms that pushes through clusters of showers really, and how that affects the atmosphere's ability to recover is going to have a great impact on the severe risk later on in the day. But we can see on the H-bar these storms do form, and they do become perhaps supercellular in nature and could support tornadoes, damaging winds, and perhaps some instances of hail as well. And we're just going to take a quick look at our storm relative helicity values, and they're going to be a little lackluster on the H-bar, suggesting that tornado threat would be more isolated. However, at our 850 winds, it's still going to be pretty favorable. Not as much as it is for the other two areas I've shown so far, but still fairly strong. 30 to 40 knots is nothing to sneeze at for an 850 jet. Really quickly, any other things before I have to switch over to the NAM? There's some things I'm missing, but we're just going to take a look at our NAM quickly. I did take a look at 12Z before recording, but now our 18Z is in, so we're, again, kind of going to try and do a little bit of a more live or improvised forecast. And we're going to see how our 850 jet does seem to come in on the NAM. Still a pretty favorable 850 jet, even if it's maybe a little more spotty. Again, that could support that isolated tornado risk. We're going to see how this handles the storms later in the day. And you can see the NAM, again, does still try and fire these clusters of storms here. Just take a sounding, see what we're looking at. Pretty impressive thermodynamic environment considering the early day convection. Yeah, the atmosphere does seem to recover a little better on the NAM 3K than what I was seeing on the H-Triple. I think I may have forgot to show the Cape on the H-Triple. I'm sorry about that. If I did, I'm really trying to rush and get through this super quickly. We're going to take a look at our storm relative helicity values now. And they look a little better than the NAM 3K, but still overall not great. So I do think the damaging winds in this mode and, perhaps western North Carolina, eastern Tennessee, and southwest Kentucky, or not southwest Kentucky, southeast Kentucky, would be mostly a damaging wind would be probably the primary hazard. But we're now just going to take a look the eastern mode in the mid-Atlantic, and let's just see what this model shows. I know the 12Z showed initiation a little further west of those supercells, and it seems like it tries to fires them down here, it seems. And then they're going to move north. And let's just see what the environment looks like quickly. Pretty, a little bit of a capping inversion there, though I don't think that would be the biggest issue. It's just that it might be because that sounding was just taken on the north side of the warm front. But no, the NAM does still show a little bit of that surface-based capping inversion. Actually, pretty sad. You can see it right there. So that is something interesting to watch. But regardless, these storms are firing, so it seems like they break through it regardless. And take a look at our Cape, and we're going to see how it's going to develop. And with time, that's going to be a narrowing instability axis as those storms close in on the frontal boundary, the warm front there. But our shear is going to remain strong. Really, it's going to be increasing throughout the time period. So wherever storms do maintain, really between 23, 24Z, which is like 7, 8 o'clock Eastern time for reference, even into a little later after that, after dark, we can see how those storms do. We can see how that environment is still favorable at the 850 jet, and we're just going to see how our storm relative helicity values handle this thing. Again, very favorable values like the H-RRR indicated. Maybe a bit further south than what the H-RRR showed. That's maybe something I'm seeing. The warm front doesn't advance quite as far north, therefore the environment sets up maybe a bit further south, but overall pretty similar scenario showing, even if the area it's showing is just a little bit different. So that is what the NAM is showing. It's also pretty sure it's showing weaker elapsed rates. We'll take a look at that really quickly. A little better elapsed rates, but still nothing too crazy. We're now going to be taking a look at the NAM 3K, and we're just going to see what this shows here. Here's our line of storms developing on 18Z, and we're going to see how these move in. And we can see on the NAM, they are a little more clustered. And so that would probably say the damaging winds is going to be the primary risk compared to the tornadoes. Though the overall environment is still going to be supportive of tornadoes, so even if we do see a little more of a linear mode, similar to what the NAM is showing, we're still going to have a tornado risk because, I mean, look, if we still have a 40 45 to 55 knot well over jet, which is a little stronger than what the HRR is showing. But both models are showing a strong 850 jet, and those are gonna, if that's overspreading where storms are gonna be, surface-based storms, then there's a pretty good chance of tornadoes, even if the mode isn't quite as favorable. And I will say how, it seems to be that favorable instability environment will spread in to there. And something I just do want to show, I remember the NAM was a little, not the NAM, the HRRR was a little more conservative on the moisture output, but we're going to see how the NAM brings these very aggressive low 70 dew points in there, and HRRR only shows about upper 60s dew points, but the moisture content with this system, with it being so close to the Gulf Coast, is going to be pretty favorable. So then that's going to lead to that strong thermodynamic environment, despite not having the greatest lapse rates or the rate at which temperatures are cooling aloft. Taking a look at our storm relative helicity values, we're going to see how the NAM 3Ks are overall pretty similar to the HRRR, however they might be just a little bit stronger as a result of that stronger 850 jet. But that is going to be the end of the video. If you liked it, please consider liking and subscribing, following me on Twitter. But yeah, I have to go. I have to go edit this and get ready for work. So see you next time. Bye.